Good morning, everybody. Welcome to 2.6 Using Formulas in Geometry. Today we are going to see some of these area and perimeter formulas in action. So make sure that you are familiar with these different key terms, and then we'll go through some examples of how they work. So for this first one, we are given a rectangle with length 18 centimeters and width 5 centimeters. So perimeter basically means to add up all of the sides. So if we picture a rectangle, length is 18 centimeters, width is 5 centimeters. That means that the opposite sides are the same length as well because it is a rectangle. So basically we'll have 18 plus 18 plus 5 plus 5. 18 plus 18 is 36. 5 and 5 is 10, so 36 and 10 is going to give us 46 centimeters. And don't forget your units. Now to determine the area, the white may be a little easier for us to see. Area of a rectangle or a square is simply length times width. So in this case, it's going to be 18 times 5. 18 times 5 is 90. And when you have area, your units are always squared. So we'll do centimeters squared. For our second example here, we again are given a rectangle. So if it's helpful for you to always sketch a picture, that is a very strong suggestion I have, is to always sketch a picture. So we have length x plus 2, and width is 2. So perimeter is where you add up all of the sides. So again, remember, if x plus 2 is this length is also x plus 2. And if the width is 2, the width on the left is also 2. So perimeter is going to be and add up all the way around. So x plus 2 plus 2 plus x plus 2 plus our last 2. So if you remember from algebra, this is a case where we have to combine like terms. The first thing we're going to combine are our x's. So we have an x here and an x here. So that means we have 2x. Then we have 2 plus 2 is 4, plus another 2 is 6, plus another 2 is 8. So the only expression we can have for perimeter is 2x plus 8. And you could say units since it did not specify the units. Now area is length times width. So it's going to be 2 times the quantity x plus 2. And then remember, anytime you have a binomial, so something that is a sum or difference when you have variables and constants mixed, you do want to use your parentheses. What this is a red flag to use your distributive property. So you're going to do 2 times x, which is 2x, and then you're adding in the middle there, so you're going to add, and then 2 times 2 is 4. So the only expression we can have for area for this particular rectangle is 2x plus 4. And again, you could say units, and then it's area, so it's squared. Now on the bottom here, they are showing us a square. So the special situation with a square is that, yes, it's a rectangle, but all of the side lengths are the same. So it's telling us that one side is 4.5, which means all of the other sides all the way around are also 4.5. So to find the perimeter, we essentially would do 4.5 plus 4.5 plus 4.5 plus 4.5. That means we have 4.5 4 times. So the shorter way is to do 4 times 4.5. Or if you wanted to write out 4.5 plus 4.5 4 times, that's fine as well. Either way, you should arrive at a result of 18. And they told us it was inches, so we have inches. Now area is going to be length times width, or in this case, side times side. So we have 4.5 times 4.5. which 4.5 times 4.5, or 4.5 squared, is 20.25. And then again, units would be inches, and we're dealing with area, so it's squared. Now, when you are given a triangle, what's important to know is the base or the bottom of the triangle and how tall the triangle is. You don't necessarily want just a random side, you need to know the exact height of a triangle. So that does have to be a length that is perpendicular or creates a 90-degree angle with the bottom of your triangle. So anytime you're given a triangle, they do typically refer to that as B, the base. But either way, what's important to know is that you know the bottom length of the triangle, and then you know the height, so that line that forms a 90-degree angle with that base. So if you notice in all these three triangles, this is a right triangle already, so there's your base and there's your height. You have a non-right triangle, so there's your base, and your height is right there. That's how tall that triangle is. That's the distance that you need to use your formula. And for this triangle, it's a different shape still. Non-right triangle, your base length is right there, and how tall this triangle is, that's the height right there. That's that 90-degree angle that's important. So anytime you're trying to find perimeter and area of a given triangle, you want to know the base and the height. And if you're trying to find perimeter, that's where you want to know all three side lengths. So perimeter for a triangle is just like any other shape. Once you know all of the outer edges, you just add them up. Area for a triangle is a little different. That is where you need to know the base and the height. So that's what we'll focus on. So it's going to be 1/2 times that base length times that height. And again, height could be one of the sides of the triangle, but if you have one of these situations, it's not necessarily one of the sides of the triangle. So for this example problem, we are given the base, which is going to be 5. So we have 1/2 times the base, which is 5, times the height, which they tell us is 2x. So this is all a string of multiplication, so multiplying from left to right. 1/2 times 5 over 5 divided by 2 is 2.5. And we still have this times our 2x. So 2.5 times 2 takes us back to 5x. And this is area, so yes, you should have units squared on there. If we were asked to find the perimeter, this example problem would need to give us the two other side lengths of the triangle, and then you would just add them with b. Now, when you're dealing with a circle, you can still find the perimeter, the length of this circular path, the circular outer edge of the circle. However, it's not called perimeter of a circle, it is called circumference. It's a special name for the perimeter of a circle. And it has a special formula. Circumference is equal to pi, which again, pi is approximately 3.14, or you could always just simply leave the pi symbol in your answer, or it's equal to 2 pi r. The reason is diameter is that distance all the way across the circle. Radius is half that distance. So a radius in this particular example could be half that distance. So you either use the diameter or you use 2 radii. Either way, that represents the same quantity because diameter is twice as long as radius, or radius is half of a diameter. So if you have a radius, use double that when you're finding circumference. If you're given the diameter, just simply use the diameter. So the area formula is pi r squared. So as long as you're given a radius or a diameter, you can always find the others. So in this first example, if we're told the radius is 7 feet, that means we know diameter is automatically 14 feet, because diameter is all the way across, radius is halfway across. And in the second problem, if diameter is 80, that means radius is 40. So anytime you're given radius or diameter, I do suggest just very quickly taking a quick second and writing what the other term is. If you're given radius, find the diameter very quickly. If you're given diameter, find the radius very quickly. After that, you can proceed to use your formula. So circumference equals, if you have diameter, it's always easiest to use your pi times d formula. It's only 2 variables that you have there, or 2 terms to worry about that you have there. So again, pi, you can leave it as pi. D for this problem is 14, so we're going to have pi times 14. And if you're leaving pi in your answer, you should put the number first. So you have 14 pi, and then don't forget your feet, because that is your unit. Area equals pi times r squared. So again, r, we're going to use 7. So this is pi times 7 squared. 7 squared, that means 7 times 7. So that means we have pi times 49. And again, if you're leaving pi in your answer, you would want to put the 49 first. So 49 pi. And again, this is our units, our feet. We should square them. And so for our second example, we have the same situation. We're going to have pi times d. So it's going to be pi times 80. And again, you do want to put your 80 out front. So we have 80 pi or 80 times pi. You can put the multiplication symbol in the middle there or not. That's up to you. And then we have centimeters. And then when we're dealing with area, we're going to use pi times r squared. So that's 40. And square it. So 40 squared, that's 40 times 40, which is going to be 1,600. And again, proper notation is to put that 1,600 out front, and then your pi second. So we have 1,600 times pi, and our units are centimeters, and because we're dealing with area, it'll be squared. So those are some examples of how these formulas work. And here are 3 questions for you to complete on your own. Good luck, everybody, and let me know if you have any questions.